Hello, my name is Jonathan Gonzalez, and today we're going to be working on point-slope form. Now, this is in addition to the past tutorial that I did on just linear equations. Now we're going to look at a specific type, another form of expressing a linear equation, which is called point-slope form. So I'll begin by writing it out. Y minus y1 is equal to m times x minus x1. Now, from this form, we can easily decipher slope. And to do so, just one thing that I'd like to point out is if I were to divide by x minus x1 to both sides, then we will have a new equation, which is m is equal to y minus y1 over x minus x1. And this can also be looked at as the change of y over the change of x. Just a little thing I'd like to point out, but back to point slope form, which is this guy over here. This equation is useful when we're given a certain amount of information, namely when we're given the slope and the point, and we're asked to find the equation of the line. So in our case, we'll look at a specific example. We want to find an equation of a straight line that has a slope m is equal to 4 and passes through the point -1, -6. So right here on top, I'm going to label my points x1 and y1. And all we're going to do is directly plug that into point slope form, and we're going to simplify it, and we would like to get from point slope form to slope intercept form, because then from there we'll know the equation of our line. So let's begin. We have y minus our y1, which is -6, put this in parentheses, is equal to our slope, which is 4, times x minus -1. So a few things I'd like to point out is that we have a negative subtraction sign followed by a negative number in both sides right here. So to do that, we know that two negatives become a positive, so I will indicate that like this, as follows. Now, our next step would be we would like to distribute the slope. So we're going to apply the distributive property, so we're going to do 4 times x, which is equal to 4x, 4 times +1, which is equal to +4, and we're just going to rewrite this, what's on the left-hand side. Now, since we want to get it in point-slope form, you want y by itself. You want to isolate that. So to do that, we must subtract by 6 to both sides. Now, when we do that, our 6's cancel out, 4x gets dropped down to the bottom, +4 minus 6, that gives us -2, and this is our equation of the line. And in our last tutorial, just with this information, we can easily graph this equation. So I'll do it just on the side so that you guys can see it. Right? Just gonna now, don't mind the spacing, but when I lay on my axis, we know that the x-axis runs horizontally and the y-axis runs vertically. Now, we're looking at our information. We know that this guy over here, this is our y-intercept. And recall that the y-intercept is the point that crosses the y-axis. So we want to locate that on the y-axis, this vertical line over here. So we're going down to this point right here. Now, all we're going to do next is apply the slope. So we know that the slope was 4, and we're going to express it as a fraction, because it's always the change of y over the change of x. So we're going to apply slope to this, so we go up 4, we rise by 4, 1, 2, 3, 4, and then we're going to go over 1. And now we have our second point. And if I wanted to get a more precise graph, I can keep on applying slope and then so that I can get a really nice graph. Next, we're just going to connect these two points together because that's what really defines a line. It's just the intersection between 2 points. And with that, this is just one of the many applications of using point slope form. In the next section, we will use point slope form in order to find ways of graphing lines that are perpendicular to another line, or maybe a line that is parallel to another line, given information such as what is the slope of the first line and maybe a point of the second line. So we'll look into that into our next section. Thank you very much.